Today we're going to talk about the 4C method and a one sample t interval for the mean. So we're going to use this problem from the book, chapter 22, number 29. What are the chances your flight will leave on time? The Bureau of Transportation Statistics of the U.S. Department of Transportation publishes information about airline performance. Here are histogram and summary statistics for the percentage of flights departing on time each month from January 1994 through September of 2019. We have an N of 309, Y bar is the same as X bar, the mean, 78.2968, and a standard deviation of 4.8758. And here's a histogram of the data. And it says there is no evidence of a trend over time, and we want to construct a 90% confidence interval. Every time we are asked to construct and interpret an interval or perform a significance test, is something we'll get to later, we will be using the 4C method. So here is our template for the 4C method. Now we have to get good at remembering all these steps so then when you don't have the template, you have all of the elements that they're looking for in a complete response on the AP exam. So the first C in our 4C method is to choose the inference procedure and set it up. So to choose our procedure, we first need to ask ourselves, do I have a mean and a standard deviation, or am I given a proportion, a percentage, or like 22 out of 80 people? So in this case, I'm given a mean and standard deviation. So we're looking at a t interval because it's asking us to do an interval. And I have one sample. I'm not comparing two means, so I have a one sample t interval for X bar, for the mean. The problem tells me to do a confidence level of 90%. And the parameter is the true percentage of flights departing from the true mean percentage of flights departing on time. In percent. So they found the percent of flights that landed on time, and then they found the average of each month. So the true mean percent of online flights. It's important that you identify the parameter. It's one of the things that they look for in the beginning of the question. Do you know the context of the problem, what you're talking about? So conditions, we have 3 conditions. The first is always check, is it a random sample? If the problem doesn't say it's random, can we assume that it's representative? So we're going to assume that the sample is representative. It was done over a long period of time, 309 months. So is it pretty representative of what's happening? Yes. So it's a representative sample, so we can generalize. We want to state that it adds to the strength of our response. The next is if we're doing a sample, it needs to be less than 10% of the population. So 309 is less than 10% of all flights, past, present, and future. So that's reasonable. So we can sample without replacement. And the last is normal or large counts. So it doesn't tell us that the population of on-time percentages is normal. It's giving us a histogram, and we don't see any we don't see any extreme skew or outliers. So it's safe to use the normal model. And then we can also say that our sample size is greater than 30, and therefore we can use the central limit theorem as well. So we're going to talk about both. 309 is greater than or equal to 30, so the central limit theorem applies. And the data shows no strong skew or outliers, so we can use a normal model. And we're actually going to be using the student's t model for a t interval. So those are our conditions. Now, we don't necessarily have to not continue if the graph is showing a strong skew and an outlier. If the sample size is large enough, then you can still move on because of the central limit theorem. So with the conditions are met, so we can perform our calculations. Our general formula for intervals is the statistic plus or minus the margin of error. The statistics in this case is x bar. Your margin of error is t star with the degrees of freedom times the s, standard deviation, over the square root of n. Now it's a little bit different if you're using proportions, but it's the same general idea. That's why that's the general formula, the statistic plus or minus the margin of error. It's the calculation that changes slightly. Then I'm going to plug in my numbers. 78.2968 plus or minus t star for 309 degrees of freedom. I'm going to pull in a table. Hold on a second. All right, we're looking at our table here. I have 309 for my n, so my degrees of freedom for my table is n minus 1. 309 minus 1 is 308. Well, clearly my table doesn't go to 308. So we always round our degrees of freedom down to the next one in our table, so that would be 100. And I want 90% confidence, so there's 90%. So 90% is here, and then 100 degrees of freedom, so 1.660. Okay. Now if I'm doing this in the calculator, I can do inverse t, and I'm going to put in 0.95 for my area because our 90% confidence interval is 90% in the middle and 5% on each side. And so what the calculator needs is this whole area from here up to this point to give me the correct t star. So, and then I could put in 308 degrees of freedom. The calculator will give me an exact degrees of freedom for that. Let me show you. Let me show you with a video. Switch camera. Start recording. With the calculator. Okay, so it's second distribution. Where is that? Here we go. Above, it's the vars button. We're going to go down to inverse t. And I'm going to put in 0.95 for my area. My degrees of freedom of 308. Oops. Let's try that again. 308. And then hit paste. And it gives me 6.498, which is 1.65 basically. Okay. So we can see that it's slightly different. 1.660 and 1.64, 1.65 is right between those two values. Okay, so we'll use the 1.660 because that's normally what you're going to have. I expect you to use the table. They expect to use the table on the AP exam as well. So it's okay that it's not the exact value. So we have 1.660 times the standard deviation, which, let's go back and look at our equation here, 4.8758, that's our standard deviation, divided by the square root of 309. Okay, you will always be dividing by the square root of n, unless it tells you it's your standard error, and it almost never gives you standard error. And so now I'm going to plug this into my calculator. Okay, so again, let me show you with my calculator. Okay, we're going to show a video of the calculator. I'm going to remember to hit record on this. Okay, so I had just put it all in and wasn't recording. So I'll just show you the way it was put in. I just put in the mean plus the t-star in parentheses, or you can just hit times. It doesn't need parentheses. The standard deviation divided by the square root of 309. I get 78.76. And then I hit second enter. So I just, when I'm here, I can just hit enter, highlight it, and then I go over and I change it to minus. And that's how I get the 77.836. And so those are my boundaries for my interval. So my answer here is 77.836 and 78.757. And the last C is conclude. We are 90% confident. The interval from 77.836 to 78.757 captures the true mean percentage of on-time flights. Okay. And then if one airline claims their on-time flights is 80%, does our interval support that? Well, if they're claiming 80%, this interval doesn't support that. So this interval does not support 80% on time because the entire interval is below that. Is below 80%.